Okay, I will now be going over all the settings for the instance render template. At the very top, you have the mesh. Here, in this case, we have a grass blade selected, the grass blade's mesh model. Second parameter is a material override. Here, if you have a custom shader, you can add that material of that shader here. Instances per unit area is just the density of the triangles. So if we look at here, the density of the instances, we can decrease or increase that. Consider area remainder is a little bit more complicated, not really that important. So we'll skip it for now. The min distance is the min distance at which things are called or rendered. And we can increase it, and it starts further at the back, and at 0 it's obviously everywhere. And max distance is the max distance to which we render. Fade distance is the distance that we fade this. You see it's fading a long way here, the higher this goes. Fade and noise range min is the range over we apply noise to the fading. So if we increase this on the min side, we can see that we get a kind of band of noise here close up. And the same would be this here for the end. If you look at the end, we get here a noise band at the end. This is really nice for merging LODs. It's really hard to notice that with this noise pattern activated. Color to scale is culling everything that is below a certain scale. If we look here, we can increase the fade distance, and you see these really tiny dots here. They are really bad for rendering for the GPU. So they're pretty damn costly and basically do nothing, right? These tiny things. You can't really even see them really. And those are really, really expensive for what they actually are doing. So we want to get rid of them, and we can do this with the color to scale per thing here. Oh, that's wrong. Yeah, we can increase it, and then everything is removed at a certain scale. Spawn height limits is just culling for height. If we do min here, we can remove. So right again. We can increase this, and then at a certain range we will cull on the height. The same is with the max height, and here the spawn height fading is the distance of which we fade along that culling. Then enable frustum culling is the frustum culling. Here, if we disable that, it's going to be really bad. Everything outside the frustum is drawn here. And occlusion culling in this case only helps a little bit, right? Because there's not so much occluded here. Disable occlusion culling. It's really all of this is just the back faces of the ground culling. Occlusion culling a little bit more, of course. Disable cull volumes. These are these volumes that cut into the instances basically and just remove them wherever they touch them, and or touch the ground. And this should be disabled if you don't need it. If you don't need it, if you don't know you need the cull volumes, disable this, click this. Same with interaction volumes. If you don't need interaction, then you should also disable this for performance. We covered this already. Steepness, noise rank. Yeah, there is steepness fading as well. If you have a steep area, for example, you can start to fade it and cull it at here we start to downscale at the steepness. That this we have 0 scale, so we basically cull it. And we can add some noise to that to make it not so obvious on the steepness seams, using the same noise as the previous noise things. Then the placement constraints, a triangle mask type. Here we have 3 built-in options. N random triangles will filter the triangles to just n random triangles. We can perhaps 40 triangles here. It will create a mask at startup that will filter out, well, everything except 40 random triangles on each one here. Let's say you want to use this asset and just place a few flowers here and there because it's really convenient to use the asset for that. It perhaps doesn't give you that much of a performance increase if it's just a few flowers here and there, but this might still be helpful for that. Random noise, same thing, but with a noise threshold. Here we can go like most triangles at 0.928, but not all, of course, right? You have this, and because our ground triangles are pretty large here. If you look at this, we of course get these large holes here. Then the most important property, the triangle mask asset, and for this you can customly define which triangles you want to keep and which you don't want to keep. And for that, you can first of all create an asset under here, triangle mask. You can then go tools, mesh painting, triangle index painter. And then you can select your triangle mask asset where you want to store this in. And we would like to paint on this thing here. So we select this instance render container. And then we can enable painting, select the brush size, and start painting whatever you want. You can make a very happy man here. There's of course very low triangle count, so this is not gonna be that detailed. We bake it into the assets, and now we have our data in this asset. And right now we have selected triangle mask asset in the instance render template. That means for all instanced render containers that have this template inside of them, we will require a triangle mask. But for this example, we will only want to provide this triangle mask for this mesh here. So we will not select it in the template. So we click none here, but instead we will actually go into here, and here we can do triangle mask override. We enable the override, and then we select our triangle mask asset, and then we can just provide the asset here. And we can see our very happy man here that we painted. We've of course some culling going on here from the steepness, but yeah, that's our man we painted. We have orients along ground normal. This I already showed. Just orients along the normal of the surface. Enable wind enables the wind and a lot of wind parameters we're going to look at later. Use texture as alpha only, R channel. This is useful if you want to have an alpha cutout. We're just going to sample the R channel of the texture. So if you have a texture like this here, where you can only see the red, that is great. You can select the format here to make it R only. That's best, so you can already see what's happening. If you have a normal texture and you just want to use the alpha will be usually in the fourth channel. So RGB alpha will be here, but we need it in here. So you can go here on the swizzle and select alpha here instead of the R channel, where the R channel would usually be. And then you have the alpha here. Then enable use of procedural coloring just makes us use the coloring, which we want to use here. Alpha clip, you can use that if you have an alpha texture or a normal texture, for example, the alpha. Alpha multiplier is a multiplier for the alpha not applied since we are not sampling any alpha. Then the texture, you can use that as a regular texture as you would anywhere else on your grass, for example, if you have some special grass texture that you want to display. However, you should know that sampling a texture is a lot more expensive than doing the procedural coloring. So if you can do something with just procedural coloring, you should always try to do that first. Same with the normal texture. Sampling a normal texture is also really expensive. That might drastically increase the cost of the rendering. Then we have the strength for the normal. Then render back faces. This will render the back faces of this grass blade here. If we disable that for a second, it will still look the same because we have the billboarding enabled right now, which makes the object face the camera always, so it doesn't matter. But if we do this, we can now see that the back faces are gone, right? If I look at this, this is the back face, don't see it, and if we go on this side, we will see it again. So for something like grass, you obviously want the back faces to be rendered. It's just a two-dimensional sheet, basically, that should be double-sided though. So we're gonna enable that. Main light shadow quality. Here you would most of the time want to select either none or hard 1x cost. With 1x cost, you just sample the shadow at an area and you can get shadows on your grass. This doesn't mean that the grass is gonna cast shadows. It means it will be able to sample shadows, and if it lies within a shadow region, we will sample, we will see that actually. So really 1x is enough to, you can't really see the other ones and they're really expensive. So you really want to avoid that. If possible, you want to select none here. This again really expensive. We sample a texture here, potentially a very large texture. We want to avoid this if possible. IsOpaque is obviously rendering this as an opaque material. So right now it's opaque, which we totally want. And if we disable that, it becomes something transparent, which kind of like blends. We really don't want this here. You can use this for the shadow cards, where you blend transparent fake shadow onto the ground. But we don't want this here. Depth test is really, if you know, you probably know what this means if you need it. We can then modify the position here. We can shift this up. This looks weird because we have the oriented along normal selected. This actually works along the normal if you have that selected. But right now we'll just go up. And you can shift to right and left. You can rotate thing. This all looks, internally this looks a little bit weird because we have this selected here. We can rotate around the Y, the X. We can scale it if we want. Yes, so here are your basically local to world transformation you would usually have. Then the droop is something that we can see very well if we disable the wind here. And it basically just bends the thing. Similar to that, the bend power along height determines how we bend. So this is very, very non-linear, and this is just linear straight bending. If you have many vertices along the object, you can take advantage of this. There's non-linear banding. This is also used for the wind animation. Then we can select a random rotation around the y-axis if you don't use the partial billboarding. You would want your objects to be rotated in a random manner probably. So this is what we can achieve with that. Then a height, the size variation, you can just vary the size of your objects along the noise that we sample, and you can see it a little bit here. Here it's small, here it's larger. It's just vary the size. Here's the noise scale. That noise scale affects the size variation. It affects the fading with the steepness and the fading with the min and max range here. We can make this a little larger here, and then it becomes really random. Or we can make it a lot smaller so we don't even notice that. Affecting many places. Then the billboard, I already showed that. That's really useful. You can also do so this is the horizontal billboard, which you probably want to use with something like grass. However, you can also do the vertical billboard and enable that as well. However, this is gonna look weird because now we have full billboarding basically. And if we look down now, this thing looks really weird. But if we go up a little bit, we will now have much larger coverage of the ground area because we fully billboard. We disable this. It's less coverage, especially if you like increase this a little bit larger. And you might enable this if you're pretty far away, but this obviously looks pretty weird. If you're close up, you're really gonna notice this double billboarding on both axes. But on one axis, it's really not noticeable. It's pretty great. So lighting is just the lighting with a specular approach can really make this stand out here. And you gotta watch out with this a little bit because this is of course affected by the rotation, and sometimes it can look a little bit messed up if you rotate it weirdly. You choose a random rotation here. This is not gonna perhaps look as you intended to do, just because the surface is actually rotated. You can make it less shiny, more shiny, whatever you want. And then you also have parameters for how much light we're actually going to receive. This is usually not something you would have, but since we're working with foliage here, it's not really. We don't really want full direct lighting all the time because there's a lot of subsurface scattering going on in such thin objects, which is really affecting the lighting situation, that we can kind of adapt this to more precisely what we really want. In some situations, this might be very useful then. But for normally colored object, you can keep this at 1:1. But for thin foliage things, this is kind of something you might want to consider. Then we have, of course, the tip color. We can modify along with bottom and regular color. So it's bottom, and this is the main color. And then, of course, we have fading parameters, so how much we want to fade this. You can also use multiple colors if you want to, up to 10. We have our wind parameters, which are shown right now. Yeah, first of all, you have strength of the wind. This is the main wind force here, so it's very strong wind. This here is how much we kick back the object. So if you have wind on a grass blade, it's going to move it forward, but at the same time, it will bounce back and then go to the opposite direction, right? So if we put this to 0, we're going to kick back all the way from front to back. But it's not that intense, so you can kind of modify how much we kick back, how much we like bounce back basically. Then we have the speed, just how fast it's going. You can really fast. This looks obviously stupid. But yes, you can also go really slow. Random offset is the max random offset each individual grass blade will have in seconds from the main wind animation, right? If we put this x0, all grass blades are going to behave identical to however the wind might behave at that position. But if we give it an offset, this is just a time offset. So with one, we have a max random offset of 1 second along the wind animations. This can give a little bit of variance into the whole animation. Then we have the wind field properties, which we can better see if we go a little bit up here. So we have, first of all, let's put this to 0. We have this main wind field we see here, and we can determine how large it is on the X, how large it is on the Y. And then we have a turbulence, which adds turbulence to this wind field. And we also have a frequency for the turbulence. So have a low frequency, we can have like these big waves in here. And with high frequency, we can have these really little small things, small turbulences. Then for within object force, we have again a strength. This is now not the primary wind force, but it's kind of an internal back and forth wobble, sort of. It's like how to describe, right? But if we put this to 0 and we disable this for a second and disable this, you can see it isolated. And it's a back and forth wobble. And it scales with the height, so we can really go overboard. We can kind of see like really that it goes along with the height here. This is of course stupid, right? But a little bit of a wobble along the height. And we always have a forward and backwards kick. Like here, we only go mostly forward. We go full left to right. And we of course have a frequency, do it really slow, do it really fast. And then lastly, we have a scaling force. This just scales the grass blade. This actually looks pretty. This makes the grass looks a little bit more dynamic. It looks good in many situations. You could also use this as kind of breathing effect on fur or something. Mixed in with other stuff, this looks pretty good. You can also modify the dimension. We can go really hardcore on this dimension here. This looks stupid again, of course, but you can decide on which dimension you want the scaling. You can increase the frequency a bunch. Yes, and that's it for the wind parameters. You can basically achieve anything you really want with this.